What is a proportion? What is a proportion? Right? It's like a part of something. Okay, yep. Absolutely. Anybody else got?
Two ratios made into an equation.
Two ratios made into an equation. Very mathematical terminology. Very good. Yep. Okay. A proportion, we'll kind of combine those, all right, is kind of like a part of something that's equal to another part of something. They contain the same ratios, okay? Basically, they are two equal ratios. That's what a proportion is. Two equal ratios. Here's an example of a proportion. Except I threw a variable in it. X over 10 is equal to 12 over 20. It's an example of a proportion. You'll be asked to solve those proportions. Lots of different ways to do it. One way works all the time. Other ways are pretty easy to think about when you have fairly easy proportions that you have to solve. What this is saying is some number over 10 is equivalent or equal to 12 over 20. Well, what number over 10 is the same thing as 12 over 20? 6, right? 6 over 10 would be the same thing as 12 out of 20. Okay? If you make 6 out of 10 free throws and somebody else makes 12 out of 20 free throws, who's the better percent shooter? Neither one. You're both 60%. All right? You're the same type of shooter. Somebody shot more, okay, but you're still getting the same percentage. Okay? On a quiz, somebody gets 6 out of 10 right, somebody gets 12 out of 20 right. Who got the better grade? Nobody. You got the same grade. Okay? Because they're the same. They're equal amounts. All right? So x would equal 6 in this case. How did you know it was 6? Just give me your thoughts. How would you know that's 6? Leah?
Well, you multiply across, so like x times 20 and 10 times 12, and you equal it together, so 20x equals 120.
So she's using cross products. You guys remember cross products from algebra? If you multiply across 20 times x, which is 20x, 10 times 12, which is 120, those two amounts are equal to each other, so 20 times x is equal to 120, and then you're saying I just divided by 20, and you got x equals 6. Okay? Good. Anybody else think of it differently?
I just used the guessing game.
The guess it, well, go, what do you mean? What do you mean?
Because 10's half of 20, so what's half of 12?
Yeah, 10 is half of 20, so what's half of 12? That's a good way to think of it. There's nothing wrong with that. Now, when they get complicated, that's when that doesn't work anymore. But absolutely, why? For some people, why go to this mess when you can just tell that's going to be equal, or you're using a little bit of math and logic behind it? That's great. There's nothing wrong with that whatsoever. Okay? That's good. There's nothing wrong with using cross products. That works every time. Okay? So, just make sure you understand that they would be equal proportions. If I take 6 divided by 10 on my calculator, and I take 12 divided by 20 on my calculator, what am I going to get? Same thing, right? Same decimal, 0.6. All right? So that's kind of a way to check your proportions. So when you're solving proportions, you can kind of do it mentally, or if they get a little bit too complicated, so if they look something like this. Unfortunately, that one I can't think, okay, well, 3 isn't quite half of 8, and crap, okay. You can't do much with that. Then in that case, you do got to go to cross products, okay. You need to take 2x minus 3 times 3, so write it this way, and set that equal to 8 times x plus 2. And now it becomes just a regular algebra 1 equation. First step would be to do what? Distribute. Yep. Good. So 6x minus 9 equals 8x plus 16. Then get all your x's onto one side, so what can I do to both sides?
Subtract 6x.
Subtract 6x, sounds great. Still got the -9 here. I subtracted 6x from both sides. Now let's get all my numbers over to the left side, so how do I get rid of that 16?
Subtract 16.
Subtract 16 from both sides. I subtract 16, I get a -25.
Divide 2.
And then divide both sides by 2, and you get -12.5. So, obviously not one you can just sit there and think, oh, I can tell that's going to be -12.5. That one's pretty tough to do mentally, alright? So that's why cross product works the best. Do you guys have any questions on this? This you remember a little bit, hopefully, from Algebra 1, to a degree. Alright, that's what the first, or the third assignment on our spreadsheet is just about solving proportions. Most of them aren't even that difficult, most of them are easier. Okay, so it'll go pretty fast. Okay? The reason I wanted to go over proportions is we're going to go ahead and apply them to some geometry. Because why not? So we're going to go ahead and use this triangle, or multiple triangles really, and set up a proportion to solve for that missing piece, that x value. And if you notice, I gave you a proportion over here using segments that can help you to set up a proportion to solve for x. So it says CB over CA. How long is CB? X units long. Okay? Absolutely. So I'll put an X in place of the CB. Here's the tricky part. How long is CA?
7 plus 1.
Nice, good job. 7 plus X. Yep. You don't know how long the whole thing is, but that part's 7, that part's X, so let's add them together. 7 plus X. Awesome job, guys. How long is CD? 12. And then how long is CE? 21. Is that a proportion we could solve? You bet. Okay? So go ahead and do it. First step would be to cross multiply. So 21x equals 12 times 7 plus x. Next step, distribute. Yep, very good. Wow. 21x equals 84 plus 12x. Get all your x's onto the same side, so minus 12x from both sides. So the minus 12x, that'll give me 9x equals 84. And last, divide by 9. 9.3 repeating, I believe. Nice. Okay. So there's kind of an example how you can use proportions to help you solve for different things geometrically. You could use these on maps. All right, if you open up a map, which I know doesn't happen as much anymore. All right, you got GPS, right? It just tells you how far it is, which is awesome. Okay. But if you ever are looking at a scale drawing of something, a blueprint, those are still real, okay? When you look at a blueprint of a house, obviously they're not drawn as big as the house, okay? So there'll be some little scale on there which might say 1 inch on our blueprint represents 5 feet in real life. So if you got to build a wall that on the blueprint, you know, is 7 inches long, you got to be able to convert that into how many feet that actually is, all right? Essentially you're using a proportion. They're not all nice like 1 inch is exactly 5 feet. They might be decimals or different things like that. So you having to set up a proportion and then solving that is definitely important. Blueprints are definitely exist still. So anyway, how you can use proportions as geometry is what I wanted to go over today. The assignment or assignments, if you will, that you can be working on are these two. First, page 360, 23 through 30. '42 and 43. And then page 367. 11, 12, 16, 17, 22, 28, 29. So not very many practice problems. They really won't take very long. There's probably about 10 here. Looks like about 7 here. So just 17 problems. They're pretty quick. Should be able to get a lot of them done here yet in the remaining time.